Hi, and welcome to our presentation about the Internet of Things. Our group name is Aware, and we are a group of 4 students, including myself, Danny, Yuki, Martin, and Misan. In today's presentation, we will talk about the Internet of Things. Let's start with the definition. According to Wikipedia, I think that's the best place to get the definition right. It's the interconnection of uniquely identifiable embedded computing devices within the Internet infrastructure. This definition is very precise and it exactly matches what the Internet of Things is. In addition to that, the Internet of Things offers advanced connectivity of devices, systems, and services that goes beyond machine-to-machine communications. It covers a variety of protocols, domains, and applications. When we talk about the things in the Internet of Things, we refer to medical monitoring implants, biochip transponders on animals, automobiles with built-in sensors, smart home appliances, smart wearable devices, or any smart device connected to the Internet. Here is some history about the Internet of Things. In 1982, the Coke machine was considered as the first concept of a network of a smart device connected to the Internet. For more than 20 years, the Internet almost depended completely on human beings to enter data into the Internet. And in 2009, Calvin Ashton, who is a British pioneer, talked about the Internet of Things as a potential to change the world by relying for the first time on devices to collect data instead of humans. Here are some facts. In 2008, the number of things connected to the Internet exceeded the number of people on Earth. And it's expected in 2020 that 90% of cars will be connected. In 2050, the prediction is that we are expected to surpass 50 million different devices connected to the Internet. That's a big number. All these statistics are from surveyanalytics.com. Now, for the past few years, some of the known products that fall under the category of the Internet of Things include the Google Glass Explorer, which is yet to be released to the market, the Apple iWatch, again, a product which is considered or put under the label of Internet of Things, and a home thermostat system known as the Nest, which was bought by Google in 2013. Interestingly enough, for the past few months, new products have been added to the market, including the Amazon Echo, which is a Bluetooth speaker that has embedded microphones and is connected to the Internet 24/7, listening to your commands and answering questions from the cloud. Another interesting product is the Dyson 360, which is a robot vacuum cleaner that can triangulate itself within your house and using a web application or a mobile application can actually do the job of cleaning your house and keeping track of what areas of your house that were cleaned. Vessel is another interesting product, which is a mug that can track the ingredients of the liquids that you're drinking, whether it's beer, wine, or juice, and can tell you the calories, amount of sugar, and other ingredients that are in your liquids. And finally, Jibo. It's an interesting idea, which is a robot that can see you and has a microphone and a camera built in at the same time. All of these products are included in our references, so if you're interested in knowing more about them, please refer to the final slide of this presentation. Let's move on to talk about the open source projects. Interestingly enough, most of the technology grows very fast when open source communities play a big role in them. And in that concept, we talk about Google, which is a leading in the industry when it comes to technology. And Google particularly has unveiled its open source code physical web standard for the IoT. It was an aggressive move by Google to put an open standard in place to connect devices such as vending machines, posters, and bus stops. Google Research which is their academic arm, is also gearing up a research grant program called the Open Web of Things to attract talent to the company, as well as to fund and give technical support to promising open source IoT research groups in the academia. Linux is a big name too, and last year they announced the creation of the All-Seen Alliance to promote an open source code framework to enable devices to discover one another and then connect and interact. The All-Seen Alliance is a non-profit consortium dedicated to enabling and driving the widespread adoption of products, systems, and services that support the Internet of Things with an open, universal development framework supported by a vibrant ecosystem and thriving technical community. It is the broadest cross-industry consortium to date to advance adoption and innovation in the Internet of Things in both homes and industries. The KVM/ARM created what is known as the ARM Virtualization System. In general, ARM CPUs became increasingly common in mobile devices and servers for the last decade. There is a growing demand for providing the benefits of virtualization for ARM-based devices. Another name is Contiki. It's an open source operating system for the Internet of Things. Contiki connects tiny low-cost, low-power microcontrollers to the Internet. There are many other names, including Eclipse. The Eclipse Foundation is allowing Java developers to connect and manage devices with an open IoT stack. Based on open source and open standards, the Eclipse Open IoT Stack for Java simplifies IoT development by enabling Java developers to reuse a core set of frameworks and services in their IoT solutions. Other names and big companies include Node-RED, which is a visual tool for the IoT. It's for wiring together hardware devices, APIs, and online services. Node-RED provides a browser-based flow editor that makes it easy to wire together flows using the wide range nodes in the palette. Another name is Mbed. It's a development platform that provides free software libraries, hardware designs, and online tools for professional rapid prototyping of products based on the ARM microcontrollers. Other names include TinyOS, InfluxDB, Raspbian, and Energia. Another good name also is Ka. You might want to look out for that. The major promoters when it comes to the Internet of Things, and when we want to talk about this section, we cannot ignore Weightless. Weightless is a global organization responsible for delivering royalty-free open standards to enable the Internet of Things. A wireless wide area global standard for machine-to-machine, short to mid-range communications. This type of technology is extremely important because it is the base of the Internet of Things. Somewhere in 2012, 4 big companies, including ARM, Cable and Wireless Worldwide, CSR and Newell, joined hands to promote Weightless. It's promoting new standards to enable the Internet of Things growth. During this particular event, Professor William Webb, the CEO of Weightless, said, "Our plan is to rapidly grow membership from our current base of 50 high-technology companies, and I would strongly encourage interested parties to join this world-changing initiative." Mike Muller, the Chief Technology Officer at ARM, said, "With common standards, we can all benefit from intelligence embedded and connected everywhere. So the ARM team is excited about the huge potential this standard will unlock." Dr. Stephen Gray, the CTO of the CSR, said that Weightless presents potential to address some of the machine-to-machine market applications, such as smart meters, asset tracking, and remote sensors. Contributing in the SIG will help the CSR to better understand market needs. Paul Broderick, The utilities business development director of Cable and Wireless Worldwide said that having another agreed standard is going to accelerate the growth and acceptance of the M2M communications. Now, just like any other technology, it comes with its merits and demerits. Let's start with talking about the advantages. The most noticeable improvements in our quality of life would be in home automation, smart household appliances to cater our needs, and health monitoring devices to monitor heart rate and blood pressure that are connected to doctors and hospitals for real-time analysis. Another point is energy saving and efficiency. The IoT enables the implementation of smarter grids through the use of smart meters, smart plugs, and the interconnectivity of household appliances, infrastructure, and the city's electricity grid. We could manage energy consumption to save more energy. Industrial automation is a big part to it as well. The IoT enables companies to remotely control the manufacturing processes and maintenance. The use of Internet of Things within smart cities is a big advantage. And the IoT enables cities' air and noise monitoring, waste management through the use of intelligent waste containers, traffic congestion monitoring, vibration and seismic readings, smart parking, and smart lighting. Moving on to the disadvantages, again, just like other technologies, privacy concerns are in the picture, and security concerns as well. These legitimate concerns are a major trade-off from improved quality of life. For these devices to be able to make decisions to assist us, they need to collect and send our data over the internet. The concern arises on who should have access to such data and what they would do with it. Another important disadvantage is that there are no standard regulations in place as of yet, and we are being over-dependent on technology. And finally, there is an increased risk of catastrophic failure. The more we rely on this interconnected system of smart devices, the more we lose if the system fails. In the end, weighing the advantages and the disadvantages and our own thoughts to this, concerning the privacy and security issue, there are ways to keep users in control over their data, granting users the rights to inquire precisely what data are sent and how they are being used, allowing devices to have a physical switch to turn on and off some features, and giving users the ability to deny access in some cases. In smart cities, the risk of catastrophic failure would be devastating. One solution is to diversify the controllers to prevent total collapse if something went wrong. Considering the benefits that the IoT brings over individuals' lives and well-being, manufacturing industry, cities, and energy, the disadvantages seem to be a fair price, but not a deal breaker. And finally, we hope that the Internet of Things will bring more opportunities to students of engineering and computer science, students looking to start their career and build a future. For more resources and links, please refer to the final 2 slides of this presentation.